C# inheritance lets you create a new class from an existing class. And it's one of the ways that we can reuse existing code uh, for a class that you've created, that you've tested, and you know all of the methods work. You can use that as your base class. And then you can create a new class, a derived class from that. In C#, the original class is called the base class. In other languages, you'll hear it called a parent or a superclass. And the new class that you're creating in C#, it's called a derived class. But you'll also hear in other languages it referred to as a child or a subclass. Typically, the derived class is going to be more specific than its base because it's going to add fields. And with the new fields, it will have to add constructors and methods to handle those fields. So to create a new class from an existing one, we use the colon operator. So we have the keyword class, and then whatever you're going to call the new class. And then to inherit from a base, you use the colon followed by your base class name. So if your base class was employee and you're going to derive a manager, it's just class manager : employee. If your base class was a club class and you wanted to create a running club, then it's just class running club : club. So it is helpful to look at uh, several different examples so you can kind of see how all of this works. In C#, inheritance is public. So other languages handle it different, but in C#, all inheritance is public inheritance. And anything that you create in your new class, you can call the base class for methods and that type of thing. So if we have a base class animal, we only have one field. It's very simple. It's name. And it's even simpler yet because we made name public. And so the only method that we created was one called display. We're going to use the default constructor, the one that C# creates. And then we have a derived class that we're calling dog. And we've got a couple methods. We've got get name, and then we've got sound. And you'll notice that get name is retrieving name, the name field from the base, and it can do that because in the base, name is public. Okay? If name was private, then we would have to use get methods to retrieve it, but it's public, so any class can retrieve it. And the first examples that we are looking at, all of our fields are public. And then we're going to get into, how do you handle private fields? And we're also going to look at a new access modifier called protected. So in our little dog class, we've got a method called get name, and we have one called sound where it says I like to bark. Then in our main method, we create a dog object. And the dog object has access to everything that's in dog and also everything that's up here in animal. Okay, and so because name is public, we can just take our dog object puppy and do puppy.name and assign it a name. And then we can call the display method with puppy. and the display method is up here in the base. And again, we can do that because display is a public method. And then we are calling get name and sound using our puppy object, and those are both from the dog class. Now, a couple rules that you need to remember in C# is that you can only inherit from one base. So we can't do something like class dog, colon, animal, colon, something else. That won't work. Okay, you can only have one base. And once you create your new class, so we've created dog, another class could be derived from dog. Okay, so you can have one base, and once you create a class, even if it's a derived class, other classes can be derived from it. All classes inherit from system.object, which is a base class. So any methods that are part of system.object, you have access to in any class that you create. And probably the one that's used most often is toString. Now, how do constructors work if we create them and we have a derived class and a base? If you create a default constructor, then what you need to do in your derived class is simply call the base constructor. And that's done. You've got public dog. Okay, so dog is the name of our class. This is obviously a constructor. To call the base, it's just colon base. Okay, and then you would initialize the new fields that are in your class, and the base initializes its own. And I will show you this in a program in a minute. For a parameterized constructor, it's kind of the same thing. The derived constructor receives all of the uh, arguments. It receives the arguments for its fields plus the base fields. And then what it does is it uses colon base and it passes along the base fields. So the base parameterized constructor can initialize using that data. So how that might look if I have a base that has, let's say, 3 fields, name, type, and color, and I have a dog class that has created age and weight. So I've got 5 arguments, 3 of them are going to the base. So I bring all 5 of them into my parameterized constructor, with the appropriate data types. And then I call base using colon base, and I don't have to put the data types in, but I do have to put in the variable names. And then I pass along the data to the base. And then for the data that remains, in this case, age and weight, I assign those to the fields that are in my dog class. So how this looks in a program. Here's my animal class, which is my base. And so I've got name, type, and color, and they're all public. Okay, and then you can see I've got a default constructor where I'm assigning blanks. And then I have my parameterized constructor where I'm pulling in name, type, and color and assigning those. Then in my derived class, I have 2 new fields. Plus, the derived class has access to the 3 fields that are up in the base. Okay, so for my constructor, I initialize the 2 new ones, age and weight, and then I call the base. And the base handles those fields that are in the base. Okay. For the parameterized constructor, we just took a look at this, but again, what it does is it pulls in all of the fields for the base and the derived class, and then it passes along the variable names for the arguments to the base. And then it takes the variable names for this new derived class, and it assigns those to the 2 properties. And you can see that I adjusted this one a little bit, added a couple more uh, methods. So I've got get name, sound, get age, and get weight. Okay, and then I've got my main method where I am creating a puppy object. And because all of the fields are public in the base and the derived class, I can just say dot name equals, dot type equals, puppy dot color equals, and then I can do the same thing for the fields that are in the derived class, puppy dot age, puppy dot weight, okay? And then I can call any method that I want directly. So this is an example showing how the default constructor is used, and this example shows how the parameterized constructor is used. So you can see with the parameterized one, the order that you put everything in is super important. So I've got name, type, color, and then I've got age and weight. Okay, and that is the order that it is expecting the data to come in. Okay, so that's the one thing people seem to mess up with constructors is the parameterized one. They put things in the wrong order. Okay, so make sure that the order that you put the data in is correct. Because C# only allows public inheritance, the relationship between the base and the derived class is an ISA relationship, which means that the derived class is also an object of the base or part of the base. So you can kind of look at it like running club. Running club is a club. A dog is an animal. If we had employee and derived manager, a manager is an employee. Okay, so those are all examples of ISA relationships, and they work for C# inheritance. Examples of relationships that are not ISA. A running club has shoes. Okay, so you would not derive running club from shoes. A dog has teeth. Well, you would not derive a dog from teeth. A manager has a headache. So you would not derive manager from headache. Okay, so all of the relationships that you are dealing with are ISA relationships. I thought it would be useful for you to see some graphics on how you can develop inheritance relationships in C#. So the first one is what we've been looking at, where we have a base, class A, and we derive class B from it. In fact, up here in the comments, I even put class A and class B so you could kind of see how that worked with the example down here. Now, this next one, we have class A as our base, And we are actually deriving two different classes from it. So class B has an is a relationship with class A. Class C has an is a relationship, but class B and C are not related to each other. So class B has access to all the fields and methods in A, plus it'll define its own. Class C has access to all the fields and methods in class A, and it will also define its own. So to see this in a program, we have our base class, which is animal, and I went back to just one field and one method. And then we've got dog that we're deriving from animal with no fields and two methods. And then we've got another one called cat, which is also derived from animal. And you'll notice that cat has no fields and three methods. Okay, cat and dog are independent of each other. Okay, but dog has access to everything that's up here in animal, and cat has access to everything that's up here in animal. And you can see that both of them are accessing the name property. Okay, and they can do that because name is public and they are both derived from animal. Okay, then in the main method, I can actually create three different types of objects if I want to. I can create a dog object, I can create a cat object, and I could also create an animal object. The dog object has access to everything that's in animal and everything that's in dog. The cat object has access to everything that's in cat and everything that is in animal. Okay, so here you can see, and if you look up here, they're accessing the appropriate methods for each. C# does allow multiple inheritance. It's very linear. So if you have a base class A and you derive class B, you can have another class, class C, derive from class B. And so what does this mean? Well, class B has access to all of the fields and methods in class A. And class C has all access to all of the methods and fields in B and A. Okay. And so another scenario that you could see is hybrid inheritance. What does that mean? That means that we've got a base and we've got a class that's derived from the base. In this case, we're calling it class B. And then we have two different classes that are derived from class B. We have class C and class D. So we already know class B can access the methods and the fields in class A. And the only reason that we've been able to directly access the fields is because they're public. Just want to point that out. If they were private, class B would have to use the get methods. Class C has access to everything that's in class B and everything that's in class A. Class D has access to everything that's in class B and everything that's in class A. Okay, and so I did a little programming example of this hybrid inheritance. So I've got my base class animal, which I tried to keep simple. So I've still only got one field and one method. Then I have a furry class that I derived from animal. So furry would be class B. Okay, and in my furry class, I've added a couple fields. I've added type and number of legs. And then I added a couple of methods. They're get methods. They're both public, and that's really important for you to look at when you are doing inheritance, um, is the access method, because public fields you can directly access. Okay, you can access them from any class. Private fields you can't. Okay, so um, looking at this, furry has basically three different fields it can use. It can use the two that it defined, type and number of legs, and it can also use name. So from the furry class, I have created a dog class and I have created a cat class. So in our little graphic, dog would be class C and cat would be class D. So the dog class is not defining any additional properties. However, it can use the properties that are up in furry, and it can use the properties that are up in animal. And so it's just got a couple methods, get name. Okay, and you can see name is all the way up into animal. Okay, and it can still access it. And then it's got a method called sound. And for cat, it also has a get name method where it's retrieving the name, and then it's got its own sound method, and it has a food method. Okay? And then in the main program, at this point, there are 4 different kinds of objects I could create if I wanted to. I could create an animal object, I could create a furry object, I can create a dog object, and I can create a cat object. Okay, I chose to focus on dog and cat. And so you can see how I have populated the fields. They're public. Okay, so I don't have to use set methods. I can just put values into them directly. Okay, and then I can also access the methods directly, because all of the methods in all of these different levels are public as well. So in the past, we've looked at assigning, one integer to another, a string to another, a structure to another. We've seen what happens when you assign an array to another. Um, and you might wonder about, well, what happens when we assign an object to another? Okay, well, you don't want to do that uh, when you are creating the object. Because remember, when you're creating the object, that's when it's accessing memory, and we want our objects to have separate locations in memory. Okay, so we don't want to do something like this. We don't want to say dog, puppy equals new dog, and then say dog Fido equals puppy. That would be bad because that would make Fido and Puppy sharing the same memory location. Okay. Um, so that we do not want to do. But C# does allow you to assign a derived object to other objects in the hierarchy. So if I have, let's say, animal, I have furry, and I have dog. The dog class includes all of the fields that are in furry, and it includes all of the fields that are in animal. So it is okay to take a dog object and assign it to furry or assign it to animal because you've got all of the data that is required. Okay, so you can take something that's kind of down in the hierarchy and assign it to the base. That is not a problem. Okay, if you do something like that, though, you want to make sure that they're separate objects. So I would do something like this: animal critter equals new animal. Okay, so now they're totally separate objects. And then I could do something like this: critter equals puppy. Now, assuming I've filled in puppy, um, all of the data that I need for critter is already in puppy. Puppy has extra data that critter doesn't have. So this assignment is allowed. So here is an example. And you can see we've got animal, and I've got dog, and each one has its own fields. And this is a little bit more fleshed out example because you can see I've got constructors and I've got several different methods in here. Okay, so we've got a little bit more going on in this example. And so here I've got a dog object, and I'm using the parameterized constructor to fill it in. And, and then I call the different methods. And then I have an animal object that I create separate here. So it's got its own location in memory. But then I assign the dog object to the animal object. Okay. And that works. Okay. They're going to basically have the same data, but the animal object has the subset. So the animal object is going to have the name, type, and color of Fido. Okay. Um, and that is exactly what happened when it printed out. Now, there are going to be times when you want to override um, a base method and have it use your method instead. And in the base, if you want to allow other derived classes to override methods, you need to put virtual in the method signature. Now, you may think, oh, well, up here, if you are looking closely, we had a get name up here in the base, and I also had a get name in my derived class. Okay, and so I did not explicitly override. So what happens is that the one that's in the derived class hides the other one. And that is actually not the best way to handle this situation. Okay, so in fact, if you get into larger, more complicated classes, you could run into some negative implications from that. In fact, Visual Studio does give you a warning if you have methods that are hiding other ones. So a better way to do it is to put the keyword virtual in the method signature. And this goes in the base. And then in your derived class, you can put in the keyword override. Okay? And that tells C# that you want to use this instead of the base. You're not hiding the base, you're using this one instead. Okay, so here is the same example with virtual and override. Exact same example. Okay, and I actually added the cat class as well because I had a get name in there. And so I was able to do override there as well. And so you can tell I've kind of highlighted the get name output for the animal. It's using the animal class. So I've got an animal critter here. And then when I call get name, it's using this one. Okay. And then I've got my dog. So when the dog is using get name, it is using this one. And then for my cat, when my cat calls get name, it's using this one. And I made them all different so you can kind of see how that looks in the output. So some key concepts to remember when you are overriding methods. A virtual method cannot be private. Well, we have been making our methods public, okay? But just kind of keep in mind that if you did want a method to be private, it cannot be virtual. The signatures of the virtual and override methods have to be identical, which kind of makes sense, right? If you're overriding a method, the method has to be identical to the one you're overriding. Only virtual methods can be overridden using the keyword override. So that keyword override kind of goes with the keyword virtual. If the derived class does not declare the method using the override keyword, it is not overriding. Okay, it is hiding. Okay, and there is a difference in how C# handles things if you're hiding versus overriding. And lastly, an override method is implicitly virtual. So for those of you that were wondering, well, what if I want to derive a new class from cat? How can I override get name? Once you use override, that makes this virtual. So you can continue to override it. Now, in addition to overriding the methods in classes that you create, you can also override methods that C# creates in its classes. And because all objects are derived from system.object, if you wanted to, you could override methods that are in that base class. And toString is a method that in all languages, it seems like people like to override that method because it really doesn't display very useful information. In fact, if you're curious, okay, well, if I'm going to override it, I'd kind of like to know what it displays. So I kind of took that animal dog example that we've been looking at, and I wrote to the console what critter.toString displays and what a dog object, my dog.toString displays. So I've got an animal object and I've got a dog object. So what it displays is the name of your namespace, a dot, and then the type of object or your class. So it's got your namespace dot class. So by default, that is what it is displaying. Now, in a programming environment where you are working on very large projects and you might be pulling in other people's code with using statements and different techniques, it may be useful to know the namespace and the class, in which case you wouldn't want to override toString. But in the examples that we're working with, where we can pretty much see the namespace name and our class name, toString is not really providing us useful information, and we can override it. So if we wanted to override it, let's say we wanted to override it in our base, all we'd have to do is say public override. It returns a string, and the name is toString. Okay, and this will override that base class method, the system.object method. So you can see I am returning some text that says animal class. I've got a carriage return. I've got the name, and I'm filling that in. I've got the type and the color. So I'm basically returning the values for my different fields. And you'll notice that I created one in the dog class as well that does something similar. In fact, I said dog class derived from animal, and then I've got all of the values associated with the fields in dog and in animal. And so then I'm just using the parameterized constructor for both objects, and I am calling toString. Same way I did it before, but now that I've overridden it, it is going to, for the animal class, it's going to use this one. And for the dog class, it is going to use this one. Okay, and so here is what that output looks like, which is a little bit more useful than inheritance.animal and inheritance.dog.